Hello everyone, this is Amit Kumar Singh and welcome to my first session on R. So when we talk about R is a language and environment for the statistical computing and graphics. It is a part of free software movement. So when we talk about R is a free software available. Although while working on statistics, you have SAS, you have SPSS, you can work on them for working on statistics. But much more better form of working on statistics, I believe, would be using R. So without wasting much time, let's try to understand how we can work on R. And basically, the first thing to work on R would be to install the R. So let's take the help of a very good friend called Google, who can help us to install R. So if I write download R, so you can see if I type R, so I'm getting two options. Either you can download R or either you can download R Studio. The first thing what you need to download when you need to start working is the R. So you have to install first R, and then after R you have to install R Studio. So when I talk about R, you can see this is the latest version of R. This is R 4.0 or 0.0. This was launched on 24th April, so 2020. So you can download R from this window. You just need to click on this, and then it will set you process by process, and then ultimately you download the R. So you can create a shortcut key on your desktop. You can see I have created a two shortcut key. They are either of 32-bit or they are either 64-bit. So you can create the soft copy of both of them. So the idea of doing this session is to talk about working on R, probably on statistics point of view. So I'm not here to talk about operating system or trying to distinguish the difference between 32-bit of R and 64-bit of R. So that won't be my intention. Now the window, what you can see, it doesn't matter you open 32-bit or 64-bit R. You can see at the top it is written RGUI. So GUI stand for graphical user interface. Now this window, what you can see here a lot of things are written in blue letters in English. What you can see, so you can see now I'm using the R version of 3.6.3. That was introduced in market on 29 February. So this version of R I'm using. You can, if you want, you can install the latest version of R, that is 4.0.0. Now you can see a lot of information is given. You can see this R is a free software and come with absolutely no guarantee. You're welcome to redistribute it under certain conditions. Type license on all that information is given. If you come down, you can see this red color. This red color, this window you can see. This when you see this red color, probably this red color, what you see, I'm just show you. This is called as prompt. This is called as prompt. So when you see the key, when you're working on R, when you see the syntax or the command on working on R, everything starts with prompt. So prompt is something which is given by R to us. So it's showing us the input. It shows us now here you can write an input. So I can write an input. Suppose I'm writing input that print. Suppose this is the input I'm writing print. Okay, so what to print? So whenever you write character, you have to start with double quotes. You can start with single quotes also. Doesn't matter. Anything you can start. So I want to hello everyone. I want to say hi everyone to everyone. So hello everyone. Hello everyone. Welcome to my class. Welcome to my class on. So this is something which I wrote. And since you started with double quote, so you are ending with double quote. If you start with single quote, you should end with single quote. Don't mix up both together. Okay. So both will not work. Here the AND function will not work. Okay. So A intersection B here, it will be null vector. So if you close bracket and press enter, so it will show you the answer. Now, if you notice, I hope you can see my screen. Now, if you notice the answer, what you get, so the prompt, that prompt command was the input. And once you put that input variable, the answer what you get, so that answer, what you're getting, that answer, it is showing you with something like this plus, it is showing you this. So it's showing, it mentioned that now the first character is being starting. So here the same thing, what information I've written, I'm getting the same information. Now imagine if you try to mix up group of both of them together. So print double quote, hello everyone, I'm writing, and I started with double quote and I'm ending with single quote. Now if you do like this, now see what happened. Now if you do like this, if you notice this plus coming, this plus means when you see this plus, when you see this plus coming, this plus basically means continuation. This plus basically means continuation. It means that the input what you have entered in your R that yet not got over. So still that it is waiting for input. So it has not processed the input. You have to finish the input. So why this all happened? Why this all happened? Because you have group of the things together. Under print, whatever you write, the R will consider that as a character. So under print, whatever you write, R will consider that as a character. So that character, what you write, either you have to start and finish that character with double quote, or you have to start and finish the character with single quote. You cannot use both of them together. Okay, now somehow I have to end this plus that is coming up. It's not given me the output. So now imagine if I use the up arrow. Imagine if you want to write the same command again. So don't waste your time writing the same command again. If you want to write the same command again, so don't write the same command again. Just use the up arrow. So if you do the up arrow, it will redo the same work. It will redo the same work. Okay, so now I have done the up arrow. Now I just go here, and because I started with double quote, so I end with double quote. Even then, because now if you understand this command is a wrong command, so it will not give me any answer. Okay, so I hope you understood. So while writing, you need to be very careful while writing the words. These things, this is very basic thing. So so what you see, this R, what you see, this is called R console. What you see, this is called R console. Okay, now if I want to exit from the R console, the key is write Q, open bracket, close bracket. So if I write Q, open bracket, close bracket, press enter. So it is asking me, do you want to save this, what you have done? You press yes, no, whatever you want, and you close it. Now I exit from this. So once you have R, the better interface than R is the working on R Studio. So you can see R Studio is there in my desktop. So now you can install R Studio like the way you have installed R, like the same way you can install R Studio. First install R, then we'll install the R Studio. So if I click on download R Studio, now if I will navigate me to this page, now here you can install R Studio desktop, install this the free version. I don't think you'll go for the paid version. So you can just install this, download this, and then it will one by one, it will navigate you to the set of windows, and ultimately you can create a shortcut key in your desktop. If you could not able to do the shortcut key on your desktop, you can write R Studio and you can get R Studio. Right. So I hope this part is clear with everyone. So once you open R Studio, you can see like kind of metrics which have 4 window. You can see it's a kind of matrix which is 4 window. So what I can do, I can divide this window into 4 parts. So once I open this, so I can see this. So 4 windows are open. This is called source editor. The top left window is called source editor. Now this is your R console. This is your R console. The same R console what you get when you open the R. So majority of the time when we are working, we work on this. If you remember the print command, what I've done. So the advantage what we get here while working on R Studio is that you don't have to write everything. So if you remembered in R console, when I was writing in the R interface, there I have to write every command. Here you don't have to write anything. Just write, I wrote P, I just wrote P. So I'm getting all the kind of options. So if I'm writing print, then again the same thing. So same thing. Hello everyone. Hello everyone. Hello everyone. Now, so I got this answer. The same thing I can write here also. So you want to clean this, you can clean this. So press delete. So here I can also write the same. Here also I can write the same thing. Now when you're writing, see, this is one used file which I worked on. So that has opened. So write print. Okay, so I'm writing. Start with double quote. So hello everyone. Hello everyone. Welcome to our class. Welcome to our class. Now if I press enter, now nothing will happen. So what I have to do in source window, you can write any file, you can create a file, and then what you can do, you can go to go to file, you can save as, you can save this file. There would be default path where this file would be saved. You can do that. And ultimately, in future, if you want to open that file, you just need to go to the top left window here. Here you can see that file. Suppose there's a file called student weight. This is a file what I saved. This is stats underscore r. This r. So I can open it from the bottom right window. What I can see in this matrix. Okay, now if you write anything here, if you give any command here, it will give you the answer in console window. Now you want the answer, I press enter, but I did not get the answer. To get the answer, what you can do, click on run. So if you click on run, you can see the answer here. You can see this answer. Okay, or the shortcut key of working on run, either you can click on run or press control enter. Or press control enter. So if you press control enter, the same thing will happen. Okay, so this window, what you see at the top left hand side, this is called source editor window. The bottom left side is this is called as the R console window. Now you can see this window. In this window, whatever work you are doing here, everything will be stored here in history. You can see everything, whatever I'm doing. I'm writing print hello everyone, all that whatever I'm writing, it is storing here in history. And in environment, you can see all the files, whatever you have saved. You can see till now whatever I have worked, all that is visible in environment. Here you can see files, plots, packages. Since R is a free software, so while working on R, you get free packages. Like you can see right now, I'm working on base R Studio. It is giving me certain package which is ticked on, which knowingly or unknowingly I'm working on. Those are data sets. They can be graphics or GR devices. So if I want to work on more packages, I can work on more packages. Now this is the help command. Because if you're confused with some key, you can search that here, or you can write here. Here you can write something. Suppose I want to know about a command called print. Suppose I want to know a command called print. So what you do, write print and press F1. So if you write print and press F1, you can see here all the information about print is visible here. So this is a shortcut key of print for working on help, or otherwise you put question mark and write print. So if you want the help on print, write question mark, use question mark, write print and press enter. You will get the print. That is one way. The other way of working on help command is write help, open bracket, and inside that write print. And then press enter. Again, the same thing will. So I told you 3 ways of working on help command. Now, if you see in console window, I've written too many things. I want to clean this. The shortcut key for cleaning is Control N. The shortcut key for cleaning is Control N. Okay. Now, if you remember, I told you in source editor, when you're working on R, in the source editor, you can create a file. So normally the file name, the file, like the way we were working on Word and Excel, we used to save a lot of documents. You can see in my desktop, a lot of documents are there. So I used to save this. So that saved in the form of file. Okay, now here, whenever you create that file is called as variable. That file is called as variable. Variables can be, they can be either numeric or they can be character, either they can be logical or can be complex. Okay, so basically we'll not talk about complex and other difficult forms of variables. We'll work on simple forms of variables. Those simple forms of variables can be either those simple forms of variables those simple forms of variables can be either numeric, or either they can be character, or either they can be logical. Now, so I can write a file name, some file. Suppose the file name is Amit. Suppose the file name is Amit. You write Amit. Okay, so already there's a file called amit.marks.class. Okay, so you don't like that file. Suppose simply before I am writing Amit, I want to remove that file. So write rm. So write rm, open bracket, write rm, open bracket, write amit.marks.class. Now what will happen? By this file get deleted. Now to see this file is exist or not, you can press ls open bracket close bracket. So if you press ls open bracket close bracket, now so if you press ls open bracket close bracket, so first let me see all the file names. So write ls open bracket, write ls open bracket close bracket. So you can see all these file names. One of the file names is amit.marks.class. I want to remove this file. So press rm, then inside that write marks.class, remove this file. So what it will do, it will remove this file. Now once this file is removed, you can press ls open bracket close bracket. So now you will not see that file name. Okay. Now, so like the same way I want to create a file here. Like the same way I want to create a file here. Suppose the file name is Amit. So whenever you create a file, so whenever you create the file, so you give a name to the file. That file is called a variable here. Then open less than sign, then dash. Okay. Now what you want under Amit? So under Amit, I want to write I want to write I want to write from I want to write the integer from 1 to 20, or 1 to 20, something like that. So this is the file. This is a file name called Amit. This is the variable. This is called variable, or this is called vector. So you can say anything. So it have the element from 1 to 20. So you press enter. Now if you write Amit, you can select both together and to run. So you can see here. So you can see here. So it is giving you answer that it is having this integers from 1 to 20. Okay, so you can see. If you want to know that this vector what you have created, what is the class of this vector? Means is this an integer, or is this is a numeric, or is this is a character, or is it logical? So write class open bracket close bracket, inside that write Amit. It is showing that it is an integer. Okay, so you want to do that. So you can test this is dot numeric, is dot numeric, and inside that write Amit. So it's telling you yes, it is a numeric. You can say is dot character. So the variable what you have created. So is this a numeric, or is this a character, or logical? So you're asking, is this a character? It is showing no, it is not a character. So anyway, so I have created a file called Amit, which have the integer from 1 to 20. So now, so what I want to do, like suppose I want the what you say, the mean, the arithmetic mean of this variable, the mean of Amit, the mean of Amit. So what I'll do, you just save this and run it. So you'll get this. So the mean of 1 to 20 you got is 10.5. Now what you can do, you can save this. Go to save as. So by default it is saving here. So you can give a name to this. You can give name something that the mean marks of Amit. The mean marks of Amit. You can save this. So R script, however, the file name specified will change into another file that you no longer. So you want to change the file name, you can see it. Okay, so it got saved there. Now, if you can save, you can see that if you want, you will come here, you can see that file what is being saved. So you can go to documents, under documents you can see that file. Go to documents. So by default, you can see if you want to know where this is got saved, if you want to know where this file got saved, so you can use the command get wd open bracket close bracket control enter. Okay, so if you do that, you will get the answer. So whatever you are writing, you want to save this. So you can see this. So all got saved uh, in the C drive users under that Sumit, under that document. Everything got saved there. Okay. Now if you want to change this, so you can change this also. You can do, if you want to change the syntax, you can change the syntax also. You want to save, you say no, I want to save this under maybe under document. I want to save this under R, anywhere you want. You can save them also. Those whatever places you want, you can use them for saving part. So that flexibility you'll get whenever you work on R window. So that kind of flexibility. So R window will help you that whenever you're working on R, so where you want to save that, so you can do that. So if you want to change it, you can write set wd and open bracket. So write with double quote. So you can write C double quote, then users, then slash, then this is somewhere, then under that documents, then slash R. So you can write everything in the double quote, press enter, and if you do get wd open bracket close bracket, it will show you the new location where your files will get saved. Okay, so that advantages you'll get whenever you are working on R. Ultimately, it is helping you to perform the kind of application what you want to work on. So this is the advantage of working on R. So the window, what you can see, you have this window is divided into 4 parts. You can see the top left part, bottom left part. The top left part is called source editor window. Now the bottom left part is called as console, R console window. Now the top right part, if you see, you have window which have 3 places. You have involvement or history or connections, and in the top right side you can see file, you can see plots. When I teach you drawing histogram or packages, so there we'll do in plots when I teach you drawing histograms and all. Now packages, lot of installed packages are there, help command is there, viewer command is there, all that you can work on R. Whenever you are working on R, you can use them. So if you remember, I have created a file. I have created a file called Amit. Just now I created a file called Amit. So if I write AMIT, press enter, so I'll get the values from 1 to 20. This is basically a file, or this is basically a variable which have all these elements, integers from 1 to 20. If you want, you can change this also. So I can write Amit, left hand key, this slash. So I can write anything. I can write integer from 45 to 67. So now if I write Amit, so it is showing me the integer from 45 to 67. Now one thing if you noticed here, you can see whenever you put any input, it will start your output with 1. So 1 basically there, it means that now that is the initiation, means from there only your output has started. Now if you notice, I have created a file called Amit there, which have the value from 45 to 67. Now if you notice, now it is starting from 45, 46, 47, 48 like this. Now maximum it has occupied in this console window, it has occupied only 17 elements. It does not consider spaces, it does not count spaces whenever it will create the element. And then then now the 18th element is starting from here. So that way you can understand this. So this is the way. So this is basically a integer, this Amit. You can see the class of Amit. So this is basically integer. So if you want, you can convert this integer, this Amit, this Amit, which is your integer. This is basically called a vector. So this vector, if you want, you can convert the integer vector into character vector. For this, what you need to do, you just need to write Amit less than key dash and write s dot s character. If you write s character, now it can convert this. Now this will convert Amit into character form. Okay, now you can type Amit. Press enter. Now you can see for all the digits they are starting with double quotes. So that shows that now the Amit has become a character. So that to confirm that, you can type class right Amit. Now you can see it has turned to a character. Now for converting the character back to numeric, if you want to convert the character back to numeric, so I can write Amit less than key dash s numeric. You can write Amit. Now if you type Amit, now it has converted into numeric part. So you can convert character into numeric, or you can convert the numeric into character. That conversion is possible. You can convert them. Now suppose I create another vector called Sumit, so less than equal to. Now the Sumit contains variables like true. So this is logical. So this is true or false. So if you press enter and if you write class of Sumit, if you see the class of Sumit, so it's showing it's logical. Now it is showing that it is. Now if you see the class of it is showing logical. So imagine, let me make it more longer. So this is C. So whenever we want to concatenate lot of data together, so we use a syntax called C. So this is a function. So when every function start with an argument, so you need to put an argument. So what are those arguments? They can be true, they can be false, they can be true, then true, then false, like this. You can press enter. Now you will type Sumit. Now you can see the same value. You can search, is this logical function? So is this logical? So you get true. Okay. Now I want to convert this logical function into numeric function. Now I want to convert this logical into numeric function. So what I'll do, so I'll write Sumit less than key dash then s dot numeric inside that I write Sumit. Now you write Sumit. You can see it is showing 10110. Here the important thing you need to understand that whenever you work on R, if you are having logical and if you are using logical function, always remember that true represent a numerical function called 1 and false represent a numeric function called 0. And so better way of saying that false represent 0, and any integer, any natural number from 1 to anything, from 1 to infinity, the true will represent. So imagine if you are converting numeric form into a logical form. So for 1 and more than 1, every integer it will show true only. So this you want to convert this. So you can see this is 1 0 0 0. So true false true false true false. So true become 1 and false become 0. So now talking about Amit. If we talk about Amit consists of all integers from 45 to 67 and all are more than 1. So if you convert that into logical part, all will show true only. So Amit dot C, Amit dot C. Now, so Amit dot, so AS dot logical, you write logical, and to type Amit, you see, you get all true. So that, I hope that part is clear with you. You can search what is the class of Amit. So it is a logical. You can write is logical. So you are getting, yes, it's true. So you are getting a picture about what way you can define the very important form of R. So the when you work on R is made of a discrete unit. So that discrete unit is called as vectors. Those vectors can be either numeric, they can be either character, or either they can be logical. So I hope I'm giving you a little bit picture about R. So like Amit, so less than dash. So what is Amit? So you can write 1. I can write Amit is an integer from 1 to 10. So 1 comma 2 comma 3 comma 5 comma 6 comma 7 comma 8 comma 9 comma 10. You can write like this. Now when you do like this, now what happened? Now this error happened. So Amit is 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 9. So this is the collection. So when you're writing the collection, what you have to do? You have to start with C. You write 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8 comma 9 comma 10. I'll press enter. Now write Amit. So whenever you're writing collections, whenever you have to use comma sign, means you're trying to bring lot of variables together, then this is basically what this is basically you are clubbing a lot of things together. So you have to start with C, or otherwise I could have written like this Amit. So less than dash, you can simply write in bracket 1 dots 10. Now if you write Amit, you can see 1 to 10. Same way I could have written Amit, then less than dash, then I could have written sequence, SEQ. In that I would have written 1 comma 10. So if I write Amit, I'll get the same. Okay. Here when you are, be careful on this, Amit dash, when you're writing sequence, don't use 2 dots. Then it will. So you can either put comma or you can put 2 dots also. So both are accepted. But only thing, when you're using file, like suppose there's a file called Amit Singh. If you're using a file like Amit Singh, now it will showing you error because space will not work here. Space is not working here. So when you create a file, Amit.sing, less than equal to, you can write 1 dot. Now you can write Amit.sing. Okay, so I hope this part is clear with you. File name, be careful. Now imagine if I type Amit Singh, no, I want the element of Amit Singh, Amit.sing. Now if I type this element like Amit dot Singh. Now see, Excel, I'm trying to make error, but R is correcting that error because you cannot write in capital or all. So you have to understand whenever you're working on R, you have to understand that Amit is different than Amit. These are 2 different things. So whenever you're working on R, these are 2 different things. So like imagine I open the R console window. Now you can write, suppose I've written a file Amit C dash. So it consists of integer from 1 to 10. Now if I write Amit, so giving me the value. Now if I write capital A, AMIT, it is showing me the error. Why it is showing me the error? Let me enlarge the screen. why it is showing me the error. Why it is showing me the error? Why this is showing me the error? Because small a and capital A, they are two different things. So there is no file called capital AMIT. So be careful whenever you work on R. That's why we prefer more working on R window, because if you make a mistake, also R window will rectify that mistake. So I hope this part is clear with you. So I have created a file called Amit, which consists of integers. I can write in descending order also, 76 to 23. It doesn't mean that it should always be in ascending order. You can write this in descending order also. So you can, there always, whenever you understand AP arithmetic progression, so you always understand it is always increase or decrease with a difference of 1. If I say no, I want a bigger difference. I want a difference of 4. Suppose I'm creating a file called AMIT. I'm creating a file called AMIT. In that AMIT, in this file AMIT, suppose I'm writing from 23 to maybe 78. So 1 minute. So this, I created a sequence. So by this working Amit. So this, so we want to write SEQ under that 23, 78. Now you can see I got the sequence from 23 to 78. Now what I want a difference of 5, something like that. I want a difference of 5. So that also you can do. A met less than or equal to. It should always start with less than and dash. It should always start with less than and dash. It should always be like that. Now you can open bracket SEQ. Then I can write 23, 78. Then comma, I can write by 5. So if I do that, now you can see. So by basically means it is talking about by basically means it is talking about the arithmetic progression where the difference should be 5. So 23, 28, 33, 38, 43, 48, 53, 58, like that. You can see the difference is 5. Okay. Now if you want to measure the number of characters, now in Amit, how many characters are there in Amit? Write length. So length will tell you the number of characters. Either you can count it manually, either you can do the manual counting 23, 28 like that, or if you want to follow, you can follow the formula of AP. What is the formula of AP? If you want to follow the formula of AP, the nth term in AP, that AN is equal to A plus N minus 1 into T. So here the nth term is 78 and the first term is 23 plus difference is 5, right? The difference is 5 and you want to count the n. You can do that work also, and with that you will get the same answer. So that homework you can do from your end. So length basically will tell you the number of characters, how many variables are there, that it can tell you the length basically do that work. Now suppose if I say Amit dash equal to then sequence SEQ, then this is maybe 78 comma 23. Now I'm writing opposite. Now I want decreasing AP with a difference of 5. Now if you do this, now you are getting error. Now you want a difference of 5, so what wrong you have done? Now I want to rectify the wrong. The wrong is that the difference should be minus 5. Now I want to rectify that. Why to write the same thing? Put up arrow, you get the same thing. Now put minus sign. Put minus sign. This should be okay. Now up arrow, minus sign, and there should be comma. There should be comma. Now Fine. So I hope this part is clear with you. So I talked about the vector. So we'll talk about vector functions, array. So under data types in R we have a data types. Under data types we need to talk about vector. We need to talk about matrices. We need to talk about array. All that we'll talk about. This is the first introductory session. So here I'm just talking about the basic elements. So here there's a one set was there called a myth. A myth consists of elements from 1 to 10. Now a myth consists of elements from 1 to 10. You can see the elements are there like 1 comma 10. So it just gave 1 and 10. I want from 1 to 10. So you can write C. 1. So So you got from 1 to 10. Suppose there's another vector called Sumit. Suppose Sumit consists of elements called 91 to 100. Now you can write Sumit. And you got 91 to 100. Now I can add Amit and Sumit together. Amit plus Sumit. If I do, you can see now you can add. So this is the beauty of R. So one by one it added 91 plus 1, 92 plus 2, 93 plus 3, 94 plus 4, like that it has added. Now what happens if Amit and Sumit have different number of characters? If you see the length, of Sumit, if you see the length of Sumit, so 10 character. If you see the length of Amit, both are 10. Right. What happens if the length are not same? Suppose this is Amit, which is having 10 elements. Suppose you are creating a vector called Smith. It has only five elements. Maybe those 5 elements are from 11 to 15. Now, if you add Amit and Smith, what will happen? Amit plus Smith. See this carefully. Now, if you see carefully what has happened, what it has done. So what it has done. So it has done 1 plus 11, you got 12. Then 2 plus 12, it got 14. 3 plus 13, it got 16. 4 plus 14, it got 18. Then 5 plus 15, it got 20. Now 6, with 6, what should it add? So again, it will start the iteration. 6 plus 11. So 6 plus 11, 17. 7 plus 12, 19. 8 plus 13, 21. 9 plus 14, 23. 10 plus 15, 25. I hope this part is clear with you. So these things will help you when you work on calculation. So R can be used as a calculator. You want to add 34 plus 79, anything. So you can add, you can divide it. So 34 divided by 78. So you got some values in decimals. Okay. Now I say no. I want till 13 place of decimal. So you can write print digit is equal to 13, comma 34 divided by 17. So you can see this. You can define that number of digits also. How many digits you want. You can do everything. You can do addition, you can do division, you can do multiplication. So 34 shift 8, 7 shift multiply means shift 8, 78. We'll get the product. Okay, subtraction 34 minus 78. Everything you can do. Now, if 78 is divided by 34, let's take a simple example. If 78 is divided by 3, what is the remainder? So for the remainder, what you do, press 2 times shift 5. So that will give you percentage sign. Shift 5, shift 5. That will give you remainder. So for finding the remainder, what you do, if you want remainder, if you want to calculate the remainder, what you will do, percentage again percentage. For the quotient, what you will do, percentage slash percentage. This is for quotient. So 78 percentage 3. It will give you the reminder. This is 0. Now 78 percentage slash percentage 3. It will give you the quotient. 26 into 3 is 78. So I believe this part is clear. You can do anything. You can do sum, multiply, divide, everything you can do. Now you can perform statistical function also. So now working on the, whenever you are working on R, so I believe you know statistics as a subject. So statistics, the term statistics has been derived from the Latin word called status, or Italian word called statista, or German word called statistic, or French word called statistique. All this means political state. The reason why the subject statistics came in existence was simply for the collection of the data during the king time, during in ancient times. So the subject was basically used to collect the number of people who are living in the kingdom, so that they can talk about taxation part, they can talk about the military part. From there, this subject is evolved with time. So you can see the relevance of this subject either in Arthashastra written by Kautilya, or you can talk about this Aine Akbari written by Abu Fazl. So when we talk about the subject called statistics, when we talk about the subject called statistics, in statistics, basically we study statistics under two parts. Either we study under it can be either descriptive statistics when we study statistics, or either it can be inferential statistics. So when we talk about statistics, it can be either descriptive statistics or it can be inferential statistics. So statistics is all about working on data. You talk about how you can work on data. So start with collection of data. The first thing what you do in statistics, you collect the data. Then next thing what you do, you talk about classification and organization of data. So once you classified and organize the data, the classification you can do different ways. Either it can be quantitative classification or qualitative classification, geographical classification, chronological classification. Once you're done with classification of the data, then the third thing what you do, you analyze the data. And once you analyze the data, the fourth part what you do, you try to infer from the data. So whenever we talk about statistics, statistics is all about data. So you work on data. So when you are working on data, when you are working statistics, there's an objective. You are doing a research. Statistics is all about research. So whenever you do a research, the units which are the part of your research, the units on which you want to do the research, those units are called as population. So if you work on, if you are working in such a level that you are working on each and every unit which are the part of your research, if you want to work on each of them, then that form of statistics is called a descriptive statistics. While sometimes when we work on statistics, instead of working on population, we take a subset of population which is called sample, and whatever the output we get on sample, from that we try to infer about the population. That is called inferential statistics. So statistics, we talk about either descriptive statistics or it can be inferential statistics. When we work on statistics, once we get the data can be either quantitative data, data can be either quantitative data, or data can be either inferential data. When you talk about, sorry, what I'm talking about, either the data can be quantitative data or data can be qualitative data. So ultimately, what you need to do in statistics, you need to convert everything into quant, everything you have to convert into number. So statistics is all about aggregate of facts, where you need to accumulate lot of facts together, and ultimately that fact should be numerically expressed. So everything you have to convert that into a number. The other name of quantitative data is cardinal data. The other name of quantitative data is cardinal data. The other name of qualitative data is ordinal data. So what ultimately what you need to do, you need to convert everything into quantitative part. Everything you need to be numerically expressed. You need lot of data together. You cannot work on one data when you talk about statistics. So when you have data with you, to get the data, either you work on primary data or either you work on secondary data. Once you have data with you, and then you organize the data either chronologically or geographically or quantitatively or qualitatively. Once you have the data with you, when you start analyzing the data, when you start working on analysis part on data, when you talk about the analysis part of the data, then that analysis, what we do, so that analysis, when you are working on that analysis, we what we try to do, we try to theoretically express the data. The spelling of theoretically can be wrong. We try to theoretically express the data. So whenever we are trying to whenever we're trying to express the data theoretically, either this theoretical description of data, when you're trying to describe the data theoretically, either you can describe by using normal distribution, either try to describe them either by using normal distribution, or you describe them by using Poisson distribution. You describe them by using Poisson distribution, or you can express them by using binomial distribution. So basically, I should write binomial distribution before the Poisson distribution. So Poisson distribution is the case of binomial distribution, where the n become infinite and the probability of success become very less. So anyway, that is not the concern. So in further session statistics, I'll teach you how to plot normal distribution curve, Poisson distribution curve, or binomial distribution curve. That we'll do in next session. Right now, I'll just go into uh, little bit of inside or normal distribution curve. So whenever we talk about normal distribution curve, the other name of normal distribution curve is Gaussian distribution curve. Normal distribution is a continuous distribution pattern. Normal distribution is a continuous distribution pattern, while binomial and Poisson, they are basically discrete distribution pattern. So basically, whenever you talk about normal distribution, it is a continuous distribution pattern, while your binomial and Poisson are basically a discrete distribution pattern. So under normal distribution pattern, you get a bell-shaped curve. What that bell-shaped curve basically talks about, it talks about that whenever you have lot of data with you, and when if you try to arrange the data in certain order, what we'll find the maximum data to be accumulate at the center. What we'll feel, we realize that the maximum data is aggregating at the center, and that nature of the data to aggregate at the center, that is called measure of central tendency. That is called measure of central tendency. It talks about the tendency, or the what to say, the tendency means what to say, the nature of the data to where the data will try to aggregate at the center. That is called measure of central tendency. So this is basically is your normal distribution curve, where you can measure your probability by with the equation 1 by square root of 2 pi sigma means standard deviation, e to the power minus 1 by 2 x minus mu by sigma whole square. Square is not coming. So this here sigma basically means standard deviation. Sigma basically means standard deviation, where mu basically means the mean. Anything and everything, either we study finance, either we study statistics, everything is based on normal distribution. Anyone who prepare for risk management exam and all, so they'll study something called stress testing, or stress testing and all. So there the idea of doing that is this like the data is not following normal distribution. So there we talk about the tendency where the thing does not follow normal distribution. So in maths, like if you know finance, if you do option pricing model like binomial tree model or Black-Scholes-Merton model, so all are based on the concept that it follow normal distribution. So it's again it is going aligning with the concept of classical physics, where the things follow an order. Fine. While when we talk about quantum physics, we say that it does not follow in order. Randomness, theory of randomness, Heisenberg uncertainty principle. So anyway, I'm not going to distinguish between classical physics and quantum physics. What we are trying to understand, the law of second law of thermodynamics. We are trying to talk something which again the second law of thermodynamics or the principle of entropy. Here we say that whenever you allow the data to aggregate according to your choice, maximum data will aggregate at one particular point, and that is called as average, and that is called measure of central tendency. So measure of central tendency basically talks about the tendency of the data to aggregate at one particular point, and that is called as averages. So in MS Excel, so if you want, if you type average in MS Excel, if you type average, it will basically, it will calculate arithmetic mean value. Like simply I'm writing some random data. So some random data between 200 to 800. So simply I wrote some random data. Now I wrote some random data. So these are my data. Now what I want to do, in if I type average here, if I type average here, so if I type average here, this what it's giving me is actually giving me arithmetic mean. So if I type average here, it is giving me arithmetic mean. I believe you are comfortable with MS Excel. So like, so in MS Excel, there's nothing called mean. So those who know statistics, they know that when we talk about average, average can be mean, average can be mean, it can be median, or it can be mode. And when we talk about mean, mean can be arithmetic mean, it can be geometric mean, it can be harmonic mean. So basically, you have to understand that Excel and all, they don't understand, they cannot differentiate between average and arithmetic mean. For them, for Excel, arithmetic mean, average all mean same thing. Okay, for median, although they have different command for median, if you want median, so you type median. So you can select the data and you get the median. What is median? You arrange the data in ascending order and find the middlemost one. That is your median. So you have to understand few part. For mode also, they have command mode. So mode basically talks about the repetition. So which data repeated the maximum. I don't think any data is repeated here anyway. So that I'm not sure about that part. And so that repetition, we can use another command to find the repetition. Anyway, that is not the concern for us. So the idea, you need to understand that when you talk about averages, average can be mean, median, mode, and mean can be arithmetic mean, geometric mean, harmonic mean. Those who know statistics, they know that geometric mean square is equal to arithmetic mean into harmonic mean. The arithmetic mean is greater than equal to geometric mean greater than equal to harmonic mean. So this basic knowledge, I believe everyone have with you. So now working on R, if I want to do the R part, now you would be wondering why I'm talking about all this. So I just gave you basic knowledge about a measure of central tendency. The same thing I can plot the same thing on R also. So going further, more than measure of central tendency, there's something called measure of dispersion also. We'll talk about measure of dispersion. Let's come back to the mean, median, mode part, because I believe now by this time you have got bored doing theoretical. Let's do something practical on R. So what I can do, I can copy this data. So if I want the mean of this, so I can copy this data. And I can go to R, I can write a file called Amit, and right, this should be the collection. But if I do like this, so now the data came vertically. Now people will not feel very comfortable with this. So let's just ignore this. Anyway, just ignore this. So ignore it, let it be. So what I'll do, I'll convert this data horizontally. So let me convert this data horizontally. So I can transpose. So now I got the data horizontally. Now I got the data horizontally. Now what if I want the mean of this is average. This is your mean. Now copy this data. Now go to R. Now write Amit less than equal to C open bracket. Now you get everything, but under C, it is a concatenate function. It should be, the data should be separated by comma, not by space, because then it will not understand that. Comma. I believe once you're done with this, this is Amit. Now guys, you can see this continuation sign, plus sign. I told you if anything does not get finished, it will show this continuation sign. If I press Amit, now you can see all my elements. If you want this in ascending order, you can write short. So you'll get in ascending order. Anyway, so the idea here is that I want to calculate the arithmetic mean. So for arithmetic mean, you can write mean, the mean of Amit. So the arithmetic mean is 591.8. You can see 591.8. Now if I say print digits is equal to 7, comma, mean of Amit. So it's not working here. So you can use that. Let me see this command, the print command. One minute. So let me see this print command. Anyway, it's not working, leave it. So you got the mean here, you can cross verify. Your mean here is 591.8. so you can see this is the way how you can calculate the mean. What can happen now, suppose there's a variable, called NA. Suppose there's a variable called NA here. Okay, now if you copy this, okay, leave, I'll do that. Before that, okay, so leave it. So let's do that. So suppose Amit slash, then this is C. Now, if I copy this, now, put comma, now put comma. It can happen that when you are working on billions of data together, it can happen that sometimes certain cells are empty cells. So when those cells are empty cells, if you import those data from Excel to R, then the R will take that empty cell as NA. R will take that empty cell as a NA. Now on that, if you perform any mathematical statistical function, it will show you error. Now if I calculate the mean of this, now you can see I'm getting an error. Now do same thing. So if I say mean here, we do with average. So you can see now the data got changed because it's not considering NA. So it is not considering that variable. So sum of data by number of data. So automatically it is not counting that. This is count. It is not counting value. You can see count account A. So you can see total 10 datas are there. Out of 10, one is NA. It is not counting that. So mathematically, for them, it's like, I hope you've seen that movie called World War Z. Who was the hero? Leonardo DiCaprio or what? In that zombie movie. So in that, the virus was not attacking those who are having some problem. So like the same way. So here for doing mathematical calculation, it is not counting those cells which have no element or they have character. It's not counting it only. So ultimately, it's not affecting the answer. But here in R, it is affecting my answer. So what I can do for that? I can write mean of Amit. Then what I can do? So mean of Amit, NA dot TM is equal to T. Okay, so if I do this, so if I NA dot RM equal to T, now see I get the answer. That is 572.7778. So you can see same answer, 572.778. I hope you have understood this. Now, guys, now going back to the old data. So Amit, so it has all these elements. Now it has all these elements. Now what I want on them. Suppose I'll go back. So if I go back and write Amit, now on this, if I noticed here on this, suppose I make a file called Amit12. In that file Amit12, that file Amit. Now suppose Amit slash equal to C, some values I'm writing, suppose 123, 345, then 567, then 889, then suppose 769, then 667, then 2344. Some values I've written. Okay. Now suppose these are the values what I've written here. These are the values what I've written here. So these are the values what I've written here. Now this is Amit. This is basically your Amit. Okay. Now if I calculate the mean of this value, so you are getting a mean as 814.8571. So you can do this. You are getting this mean. So your values are 123, 345, 567, 889, 769, 667, 2344. These are the values. Now these are the values what you get. Now if you notice, in this value there are two values which are very extreme, like 123 and 2344. They are extreme values. You can, if you see the range, you can find the range of Amit. So you can see the extreme values. So the range basically, it is a part of measure of dispersion, and there we talk about the difference between the upper value and lower value. So you can see the difference is too much. While when you see the other values are much more very close to each other. So much other values are much more very close to each other. So better way of doing that would be suppose 12, comma 456, comma 458, comma 459, comma 467, comma 489, comma 493, and then 2344. Something like this. Now, if you have not put the C, so Amit slash then C, then it was should be 12, comma 456, comma 458, comma 459, comma 467, comma 489, comma 493, comma 2344. Now if I see, so it have these elements. Those elements are 12, 456, 458, 459, 467, 489, 493, and 2344. Imagine if I find the mean of them. So the mean of this is 647.25. The mean of this is 647.25. But if you realize one thing, the majority of the values is between 456 to 493. If you understand, if you ignore 12 and if you ignore 12 and 2344, if you ignore these two values, then you realize that majority of your values are between 456 to 493. But because this 12 and 2344 is shifting the mean towards something else, so it can happen that tomorrow when you are doing some kind of calculation, there would be some kind of variables which which are not significant for you. So which ultimately is creating a lot of dispersion with you. So you can, I have calculated the standard deviation. So standard deviation for sample you can calculate by this formula. So you can see that standard deviation, it has huge dispersion. So it has huge dispersion. So ultimately this will affect your end result. So what you can do, can you ignore these values? Yes, I can ignore this value. So what I'll do, I'll find mean. I'll find mean equal to Amit. And this I say trim 10% of value here and there. If you trim also, then also you're getting 647.25. Okay, 1 minute. So if you're ignoring 10% value also, then also let me write this value in Excel. So suppose your values are 12, 456 and 458, then 459, then 467, then 489, then 493, and then 2344. So if you calculate their mean from here, so this is 647.25. Okay. Now if I want the average, where I don't want to include them, neither 12, neither 2344. So it should be 470.33. Trim this value. It should be trim 0.1. Something like this. Suppose your data, what I want to show you. Suppose if I take your data as 123 or 156 or 178 or 189 or 213, 244, 344 and 1098. Let me do this. So suppose Amit is equal to slash C So Amit is equal to less than C, open bracket 123, comma 156, comma 178, comma 189, comma 213, comma 244, comma 344, comma 1098. Now suppose this is Amit. Now these are the values. If you find the mean of Amit, you are getting 318.125. If I say tell me the mean of Amit, comma trim 10% of value. So I'm getting the same values. So the trimming part is not working properly. So ideally it should ignore these values. It should remove 10% up and down. So you should ignore this 123 and 1098. So that part is not working here. So if I say mean of Amit, trim 123, we're getting 201. So if you ignore 201, so mean of Amit, trim 123 and 1098. So still you are getting the same value. So if you say Amit, now you're still getting the same value. You want to trim. If I say mean of Amit, trim 123, comma trim 1098. Now it is not accepting it. Formal argument trim matched with the multiple actual arguments. So error in mean.default. So mean of Amit, comma trim 30% of value. You're getting 206. So you're getting this value called 206. If I say mean of Amit, trim 40% of value, 201. So should be mean of Amit, trim 20% of values, 220.666. So ideally, the idea of using trim should remove that much values, which is ultimately affecting your answer. So suppose here, I believe out of all, so because I cannot remove 123 and 1098, let's remove 1098. So mean of Amit is equal to trim 1098, because 1098 is affecting my answer a lot. So you're getting the answer called 201. So let's confirm these values. Let's confirm this with MS Excel. Let's confirm this with MS Excel. Let me write down these values. These are 123, then 156, then 178, then 189, then 213, then 244, then 344. I want the average of this. $206.718 you should get. 206.718. Even then, if you are removing this, so if you find the mean of, if you find the mean of Amit by trimming 1098, here you are getting 201. It should be 206.71. Anyway, so you can work on these parts. You can figure out the idea of using the trimming part is to erase that value, is to figure out those values which are not significant for you. You can, if you can erase them, then it can serve the objective. So if it can serve the objective, so then it can work for you. So anyway, the idea is that it should help you to remove the value. Suppose you have some values like this. Suppose you have some values like this. Mm, So some values like this, where one of the values Na and one of the value is something which is very big value, so which can affect your answer. So by using trim command, so whenever you use trim command, so by using trim command, what you can do, by using trim, you can remove certain percentage of value which can affect your answer. And by using rm.na command, you can rm.na equal to t. You can remove while working on R if you are getting something called na. So that way it can help you to work on that part. So that is the way. So endless equal here. So a lot of files are there. So this is a file called Amit. So for this, so Amit equal to Amit is equal to any value from 455 to 489. Amit is 455 to 489. So what is Amit? So this is your Amit. So these are the values what you have in Amit. So if you want the sum of these values, write the sum of these values. So this is the sum of these values. If you want the count, so the count of this, the count of this. So the count of this is 35. Now what I can do, I want to find the average. So let's define a variable called A. A means the sum of Amit. A means the sum of Amit. What is A? A is 16520. And suppose there's a variable B. B means the length of Amit. Now, so you know that what is the formula of average. You know that the formula of average. You know that the formula of average. You know that the formula of average is sum of data. You know that the formula of average is sum of data that you divide by the number of data. This is the formula of average. So you know that this is the formula of average. Now, if I press enter for R, this is something which is active. I want to. The reason why I've written this, I wanted to just show you that this is the formula of average. So you want to make that given prompt command inactive, input as inactive, put shift 3 hash before it. Now you can see this the given command has become inactive. So now R will not give anything on that. Now to find the average means arithmetic mean, what I mean. So mean here is what is mean. Mean is A divide by B. What is your mean? This mean is 472. Okay, or you could have done like this, mean of Amit. Or what you've done, you would have found the mean of Amit. You get the same value. Simply, I just thought to use mathematical part of that, and you do that, you'll get the same answer. You'll do the mathematical part of it, and you do anything, you'll get the same answer. So this is the way how you can do. Now in this Amit, now Amit was basically from 455 to 489 elements. On this, I want to add an element called 1098. Okay, so I put C here. So this is 455 to 489. On this, I wanted to add an element called 1098. Now, if I see Amit, so it have all the element except, and then one more element is added called 1098. So if I find the mean of this, so the mean of Amit is 489.3889. Before the mean was 472. Now the mean is 489.3889. Let's see this. Trim is working. If trim will not work here, then I leave it. Then will not work on, and that is insignificant. This is 0.1. So now you got 472.5. Now you understood the use of trim command. So what I did, because before I was using random variables, so because of which I was finding difficulty in using the trim command. Now what I did, I took sequence of numbers, the n natural numbers together, and then I just introduced one variable. So and then the trim command is working here. So now what we have learned, how to introduce a variable. Now I believe you would have learned how to introduce a variable, and then what you have learned after you introduce the variable, the next thing what you have learned that how to use a mathematical formula by giving a name, by giving a vector name to that, and then you learn simultaneously mathematically how you can find that. Now if I ask you the median, of Amit, so you will get the median. You arrange the data in ascending order, and you know that median is not affected by extreme value. So that's why your answer will not get affected. So you can see the length. If you see the length of Amit, this is 36. When you get the answer median in decimal, you should understand. I believe you would have understood that why you're getting answer in decimal, because whenever your number of data is even, so when n is even, then your median is basically, it is the arithmetic mean of n by 2 observation plus n by 2 observation plus 1 observation divided by 2. So you can see here 36 observations are there. So your mean is the arithmetic mean of 18th plus 19th divided by 2. Okay. Now if I want the 18th observation, that Amit 18th observation, so that 18th observation is 72. So what I've done, if I write Amit, so it will give me all the data, but I want 18th observation. So for 18th so for any observation, you want, write the vector name. The vector name was Amit, and use square bracket and write that nth element, which element you want. Now suppose I want 19th element. So Amit square bracket 19. I get 472, 473. Now Now the answer is the arithmetic mean of this. So your answer is 472 plus 473 divide by 2. So your answer is the mean of 472 comma 473. So you're getting wrong answer. You're getting wrong answer because you have to assign a file name. So you have to introduce a file name. Suppose C is equal to 472 comma 473. This is your C. Now find the mean of C. Sorry. So that was 472 and 473. This is your C. This is your C. That is 473. Now find the mean of C. You got the 472.5, or if you write 472 plus 473 divide by 2, you get 472. Any way you do, you'll get the same answer. The idea of doing all this is to just to make you practice on how you can work on mathematical and statistical part. Now let's introduce a variable called Amit. That Amit is basically something maybe from 472 to 489, 489, comma 474. So median part is done for you, 474, and again 474. Okay, so net is equal to slash C, because of the UC here is to be 472 double quote 489 comma 474 comma 474. Now this is your net. So you can see, now I want to work on mode. So in order to work on mode, what I need to find the data which repeated the maximum number of times. That's why I wrote 474 purposefully 2 times. So there's no direct command in R for working on mode. For that you can write a table. You can create a table. So you can create a table. Just simply write a file called submit. Submit is basically a table. It is a table. Now you can notice here. You can now, by looking at this, you can figure out which is the mode. The mode, you can see the frequency. I believe you know the class interval and frequency. The frequency is the maximum for 474. So the 474 is your mode. Clear? Anyone have any doubt? Anyone have any doubt? Please ask to me. If anyone want to ask anything. Now, if I want, what I can do, I can write short submit. So if I short submit, so I'll get these values. It's very easy to figure out which values having the maximum frequency, or you can write short submit, comma decreasing equal to T, capital T. So by this you can so first when you shorted, it shorted in ascending order. Next time when you shorted, it shorted in descending order. So that way you can easily locate your mode part. So once you have understood the measure of central tendency, So measure of central tendency is the nature of the data you aggregate at the center. Now, whenever you find the measure of central tendency, not all the data will be aggregated at the center. The data can be dispersed from the center, and that we'll study under measure of dispersion. This measure of dispersion talks about how your data is dispersed from the center. So in that, we can talk about range, we can talk about range, we can talk about quartile deviation, we can talk about range, we can talk about quartile deviation, we can talk about mean deviation, we can talk about standard deviation. There are a lot of tools are there to study the measure of deviation. Standard deviation is normally represented with sigma sign. So when I talk about range, what was range? Range was basically highest value minus lowest value. When I talk about range, range is basically your highest value minus your lowest value. That is basically is your range. Okay. Now you have studied median. What is median? You arrange the data in ascending order, find the middlemost value. Okay, that is the median. What is once you understood median, then the next thing you have to understand is quartiles. So median is 50% of data. Median is 50% of data. So median is 50% of data. While what are quartiles? If you arrange the data in ascending order, then first 25% of data is called lower quartile or Q1. Then 50% of data is called as quartile 2 or median. And then first 75% of data is called as quartile 3 or upper quartile. So quartile deviation nothing but it is Q3 minus Q1 by 2. Okay, so here uh, in R, what you can in R, if you want to work on R, so if you want to work on R, so if you want to work on R, let's see Amit, all are there in Amit. You can see this value, so you can find the range of this value. So you get the range of this. Similarly, you can find the quartiles. So quartile is nothing but the function you have to use is quantile. Quantile, if you write Amit, so you'll get this frequency distribution that where your 25% of data lies, where your 75% of data lies. If you notice here, 25% of data lies at 474.75 and 75% of your data lies at 484.25. So how to find Q1, how to find Q1, Q3 and all. So what you do, you arrange the data in ascending order. You arrange the data in ascending order. You arrange the data in ascending order. Then the formula of Q1 is n1 into n plus 1 by fourth observation. This is the formula of Q1. The formula of Q3 is 3 into n plus 1 by fourth observation. So this way we find Q1 and Q3, and then we can follow the logic of interpolation to get the answer in case of doubt. And so suppose if you get something called 3.75th observation. So 3.75th observation would be third observation plus 0.75 into fourth observation minus third observation. So that all you can do for these kind of scenario. When you study statistics theoretically, you can do this thing very easily. Now to find the quartile deviation is nothing but Q3 minus Q1 by 2. So when I talk about quartile deviation, that is Q3 minus Q1 by 2. Then there's something called interquartile range. Then there's something called interquartile range. Interquartile range is nothing but Q3 minus Q1. So that is interquartile range. So in R, you can find interquartile range very easily by using the function called IQR. So if you type IQR and type it, you get the answer called 9.5. This is nothing but this is 484.25 minus 474.75. That give you the answer. If you want quartile deviation. If you want quartile deviation, so quartile deviation is nothing but that is IQR bracket with divide by 4.7. Okay, so you can do this. Now talking about standard deviation. So if you want to know about standard deviation, so next thing you have to understand is standard deviation. So the formula of standard deviation. If you want the standard deviation for population, like if you remember, I told you statistics. In statistics, you can study population or you can study sample. So the standard deviation of population is summation of x minus x bar whole square by n. This is a formula of standard deviation for population. While talking about standard deviation, while talking about the standard deviation for sample, for sample, we use the formula called summation of x minus x bar whole square by n minus 1. So this is the formula for the standard deviation for sample. Okay. The same thing you can do in Excel also. Now your Amit values in Amit, these are the same thing. If you use the command called SD and write Amit, so this actually gives you the standard deviation for sample. This actually give you the denominator divide by n minus 1. That gives you that value. Suppose if I define something called Vikas means standard deviation of Amit. Okay, so I'm just introducing. So when I write Vikas, so this will give me the standard deviation of sample. Okay, now I'm writing, there's a variable called Suman. Suman basically means the length of Amit. So the length of Amit Suman is 20. Okay, so it would have been better if I use V and S. So better write. It would be better if I write N only instead of Suman and all. So less than equal to length of Amit. So N here means 20. Okay, and standard deviation of sample. Let's use the word called standard deviation. That means standard deviation of sample. Okay. So now what I want now this formula, what you see, the formula in R, this formula SD, small letter SD, okay, not capital letter SD, it's a small letter SD. The small letter SD will give you the standard deviation, of sample. Now if you want the standard deviation of population, then what you should do, if you see this formula, what you should do for getting the standard deviation for population from the standard deviation of sample, I want this formula. What I'll multiply the standard deviation of sample, so with square root of n minus 1, and that I'll divide with n. Then I'll get the standard deviation of population. I hope this is clear with you. The same thing here you can do. So you can write standard deviation of sample into SQR square root of n minus 1 divide by n. If you do this, you'll get the standard deviation of the population. The same thing you can work on Excel. in Excel, if you type std, you can see stdv.s. This will give you the standard deviation of sample. If you put p, it will give you the standard deviation of population. Okay, so I hope you are understanding this concept. This is clear with all of you. All this I've done for you. So this part is clear with all of you. Fine. So basically, when we talk about R, so you can directly, if you want to install R directly, you can go to the CRAN network. You can go to CRAN network. CRAN stands for Comprehensive R Archive Network. So if you go to Comprehensive R Archive Network, there's a direct link is there. With that you can install R. And once you install R, you will get this graphical user interface. Either you can open 32-bit or 64-bit. You and the window, this is called console window. You can work on them. Or if you want, after you open R, you can open R Studio, and ultimately you can work on R Studio. And so when you work on R Studio, basically so you can do multiple work at the same time. That way it will be helpful for you. So R is a free software. This R can work on Linux. It will work on Mac operating system. It works on Windows. So the R, when you talk about R, so the R basically was developed by two mathematicians. Those were Ross Ianca and Robert Gentleman. And they developed this free software when they were teaching together. They were basically colleagues in University of Auckland, New Zealand. So there they developed this free software, and gradually with time, lot of people came together, and they all started working together, and ultimately in February 2000 they came up with the first version of R. So I hope you have understood whatever I have done till now. So it's the time that I should say thank you everyone for your support and giving so much time to me. It's a time that I should say wind up this class. I hope you have enjoyed this session. So this thank you also. I am writing a code for in R for that. So that way I'm ending this session. I hope this was a learning session for you, and you have learned a lot from this. So any moment of time, if you're finding any difficulty, you can pause the video and you can see what is being done, and you can re-examine everything. So R is a free software. In any case, you can write that command. Any command you have doubt. Suppose you have doubt with print, write print press F1. You'll get all the information about that. So that kind of comfortability you'll get while working on R. This is the first introductory session on R where I try to focus myself more on mathematical and basic or statistical part. So gradually in further sessions we'll do more and more output like this. I hope you have learned something from this session. You enjoyed this session. So with that intention, it's a time to wind up the session. Thank you everyone. God bless you. Bye.